So if you had you were trying to find the average speed, you had, let's say, 13 meters per second over a certain time period, and you traveled at 26 meters per second over a different time period. You guys know how you would find the average of any two numbers. Add them together, divide by 2. So 39 divided by 2, 19.5, right? Yes. Yes, you could have, yeah, you absolutely could have 3 speeds, then you would divide by 3. You guys act like this is not common sense. You guys don't know this? You don't know how to find an average? That's one person. You know how to find an average? Anybody else? You know how to find an average? Nobody else knows how to find an average. You don't know how to find an average? Yes. Why don't you raise your hand? Emma, you know how to find an average? Yeah. Okay. Audrey? Okay. Is it hard to raise your hand? Yeah. It is? Why? You're tired?
Because it can be us, so you don't know what you're ready for.
Well, I'm pretty sure everybody in here knows the answer to that.
I know.
So it's not awkward if you know it. It's awkward if you don't. And even then, it's not that awkward because it's not that big of a deal. Okay. What does instantaneous mean?
Right now.
Right now, at an instant. So if I'm saying, if instantaneous means right now speed. Okay, is there anything that you are pretty familiar with that tells you the right now speed? Speedometer. Where do you find the speedometer? In your automobile. Yep. Okay. Rate at a specific time or a certain instance in time. Now we're going to spend, when we're talking about speed, we'll be talking about average. If you're trying to find instantaneous speed, you would have to be given a pretty fair amount of data, or you would have to use calculus, which I'm sure you guys don't know how to use calculus yet. Who can raise your hand and say they know how to use calculus? That actually worked. Let me see. Don't put this in yet. I'm going to skip this one. We already did the speed equation yesterday. Okay. Velocity. Distance is to displacement as speed is to velocity. Okay. Velocity is to speed as displacement is to distance. Okay. Velocity is to displacement as distance is to speed. Distance is to distance as distance is to
Distance.
all right. There you go. When you're done putting this in your regular portion of your notes, go ahead. Get that variable in the back of your notes. Anybody here ever played Space Team? Space team. Wow. It is a mobile team game. Kind of curious. A phone team game. No, mobile. Okay. No, okay, yeah. A phone team game. They're not a, hold on here.
Looks boring.
Okay, play with me during, when you don't have. Was it small groups today?
Yeah.
Space team.
Apparently,
Space.
it sounds.
It sounds dumb, and it looks dumb, but it's kind of fun.
Is it like a one-person game?
No, it's a 2 to 8 person game. And basically, you're just all yelling at each other the whole time, trying to keep the spaceship alive.
Oh, wait, really?
Oh.
Yeah.
Like actually yelling or yelling?
Yeah, like you have like things on your screen that are specific to your screen, and like somebody else has to say, initiate the turbo thrusters, and then you have to like see it on your screen and do it.
Who do you play with?
Anybody you want.
Like random people?
No, you have to have people in the same room. Because like I'll say something and it'll be on your screen, you gotta find it and do it. If you don't, we're in trouble. And then you gotta say what's on your screen and I gotta find it and do it. And so it's just basically a bunch of people yelling at each other, trying to find all the.
Dude, we gotta play it. Yeah.
Okay, here's your equation. Ready for another equation?
Yeah.
We have v, which is velocity, is the change in x over change in time. Now it would make sense that if velocity is a vector quantity, that we should probably also have a vector quantity in that equation. What is the vector quantity, not velocity, that's in that equation? Displacement. Which is displacement? That's x. Okay? If we're using the position variable that's velocity, we're probably using the speed velocity equation that is also your vector quantity. Okay, so looking at this example, who can tell me what it is that makes this velocity? Looking at the example, what is the thing in here that tells you it's velocity? That guy. Because if it didn't have that, what would you have? Speed. Right? Just like with distance and displacement. If you just have 12 meters, what is that? Distance. But if I say 12 meters, now what is it? Displacement. You with me, Audrey? Sure? Okay. You have cute nails, by the way. All right. Is it? I got her to actually like eat cake. That's awesome. Okay. What's rate meaning at? Just quick reminder, refresher here.
How fast?
How fast? Okay? So it's how fast you're displaced. Okay? Now, we also know what does this little delta mean? So this would be another way to write this. Velocity is the final x minus the initial x over your time frame. I'm not going to, typically we don't do change in time because they don't usually give you two different time numbers. They usually just give you the change in time. Okay, so just to be aware of that. You might want to have this in just in case you do not know what change in means. Okay, change in is always final minus initial, no matter what the variable is. So if it's change in time, what is it? Final time minus initial time. If it's change in velocity, what would it be? Final velocity minus initial velocity. If it's change in birthdays. Yeah, hopefully you're not on your final birthday. Okay. So here's just a verbal way of showing you the main difference. I think you're good. Hopefully you're good at this point that you can really distinguish the difference between a scalar quantity and a vector quantity, and that you maybe don't need this slide. But if you're still, working on trying to distinguish the difference between a scalar quantity and a vector quantity, it's good to have this. How many of you outside of class looked at your notes yesterday? 2, 3, 4, 5? Good job, those of you who looked at your notes outside of class. So this says velocity is a vector y. Y is velocity of the vector.
Does it include surrounding direction?
Yep. Because it has a. So keywords here. Vector has a direction. Okay? Scalar only how fast? No direction. Okay? Questions?
No.
Guys all good?
Yes. All right.
This kind of puts it all into one little box for you. And the reason why I do want you to put this in, even if you're good at it, it organizes kind of a big amount of notes. And change this to S. I don't know why they do that. They use speed and velocity as the same variable, as if you could just distinguish the two without even thinking. But this is going to take our two really important vocab words that we talked about, right? These were our two most important vocab words, really probably for this whole chapter. And it takes probably our four most used variables for doing math in this chapter, and it puts them in a nice, neat chart here for you. Yeah. I know, but you wouldn't be able. You can't really tell that. First off, also it's very difficult to draw italicized V well. Would you guys be able to write a good italicized V? It's all italicized. So you wouldn't be able to do a normal V.
Where's the next thing?
Oh, yep.
Oh, I just wrote down.
No! Good catch. Change an X. Your book likes to be real cool and just have it italicized versus not, which I think that's very unpractical. Because, we're going to be using these variables all the time, so unless we're good at doing italicizing things, it's going to be hard to tell the difference, right? Okay. There we go, Bob Jones all over again. Going screwing it up. Maker of your book. Come on, Bobby! And remember, vectors can be positive or negative y. Why can vectors be positive and negative and scalars can't? Because a positive and a negative sign tells you a positive and a negative sign tells you a positive and a negative sign tells you
Direction.
a positive and a negative sign tell you
Direction.
yes. Did you guys think I was trying to get something else out of you or what? No, I'm just trying to actually get a few of you to open your mouths. Okay? Don't put this in I think I've kind of already made this very clear that negative is representing west, positive is representing east. What is south? How do you represent south? Negative. Okay. What's the problem? How about it? How about it? Let's do a problem. Write this down, and then we'll do this problem. And then I'll have you do one on your own. How about that? I will make you do one on your own. See if you guys can do math. Do 7th grade, one variable change math. Oh, they actually gave us some nice things here. This is where you're going to start seeing something a little bit maybe unconventional as far as something that you're not used to, because in math it always just gives it to you, but in physics and science it doesn't. Okay? So what did I say the very first thing to do when you're doing these physics problems for your variables? Identify and label your variables. Okay? Raise your hand if you know what one of the variables is. Go ahead.
West.
West is a variable?
Oh,
Nope.
shoot.
It's okay. You know one, right?
Yeah.
Give me one.
Time.
Okay? What is time?
21.9 seconds.
Okay, and how'd you know it was time?
30 seconds.
This is the seconds. Okay? Wilson?
Speed 52 meters.
Okay. This is where it gets difficult. It's not speed, and here's why it's not speed. Because you have displacement, and you also have a direction. So it has to be what? Velocity. Now that's tricky, because doesn't speed and velocity have the same common unit?
Yeah.
Here's another tricky thing that you do not know yet. What does west tell you? Negative 52 meters per second. Did everybody catch that? It doesn't give you the negative. Well, it does, but it does so here. Everybody hear that?
Yeah.
So, you need to know what are negative directions and what are positive directions. I have said this already, but what are my two positive directions? Someone raise their hand.
Northeast.
North and east. Okay, well, then my two negative directions would be south and west. You got to remember that. Because if this said east, you wouldn't put a negative on it, you would just leave it. Right? You wouldn't have to put a positive, right? You don't usually put a plus in front of a positive number, correct? Alright? And what are we solving for? Displacement, what is its variable? Change in. Now do we know what equation we're using? Velocity is change in x over my time. Let's now plug in numbers. Negative 52 meters per second. That looks like that's smaller. Alright, raise your hand if you think you know how you solve this. First of all, can you tell me, do you remember the two things that have to be true when solving for a variable? You remember? Eric, you remember? One of them? Can you give me one? Yes, the one we're solving for has to be on top of a fraction. That's actually the harder of the two. What's the other one? Rose? Yeah, the x needs to be alone on one side of the equal sign. Does it have to be on the right or the left? Is there one side that it always has to be on? No, you just gotta have it alone, okay? Currently it's not alone, it's with some random 21.9 number up here. So we gotta get rid of the 21.9. How do we do it? Give me Cassidy. Okay, gotta get rid of this 21.9. Currently I'm doing what? Dividing. Okay? To undo division, you multiply both sides. 21.9 cancels out. Do the same thing over here. I'm running out of space. 21.9. I'm going to keep the units so that I can show those. You're changing x. You should have your calculators out and ready to plop this in. It's going to be a relatively large number. We'll get
Negative 1,138.8
1,138.8
meters.
And how did you know it was meters?
Okay.
Okay, there's two ways of knowing. Okay, there's one, just knowing it is a good way, but the better way is being able to look at and cancel out units correctly in math. We've got a second that cancels out with a second on bottom. Like if I have a 2 over 2, you would cancel those out to 1 over 1, right?
Yeah.
So if I have a second over a second, those will cancel out. That's on top, that's on bottom, and you're left with meter. The second way would just be to know that if this is in your common unit and your velocity is in its common unit, then your displacement will be in its common unit. Now, did I give a direction on this? I technically did. There's a second way to write this that would also be correct. Any ideas? Ooh. Yes. But you have to get rid of the what? So this is one correct way to write it. This is another correct way to write it. Why would a negative number, then putting a west on it, why would that not be okay? It'd be the opposite of west, which would be what? East. Okay? So I don't care what you decide, if you want to keep the negative on it. And it makes sense, if you're going at a certain velocity west, your displacement better be west, right? You can't be displacing east and be traveling west. That doesn't make any sense. Okay? All right, I am actually going to do this one with you because I didn't get to show you one like this yesterday. Okay? To get this in, to have, not just work without any information. How long does it take a bicyclist to travel 34 meters if he sustains a velocity of 2.3 meters a second north? One variable, please. Anybody? Ethan? Velocity is? Okay, so if it's north, do I have to do anything with this number? No. Everybody catch that. It's north, so it's positive. You don't have to actually put a plus sign. If you want, you can. But if you don't have a sign, what are you inferring that it is? Positive. Yes? I did. You are right. I'm so glad you caught that. I'm just making sure you're on your heels. You're on your toes, I mean. On your heels, that means the opposite. Okay. Oops. Okay. What other variable do I have? Derek? What's it called? It's right there in my brain. Displacement. Which of these two variables is displacement? Okay. Delta x, 34 meters. And it says how long, that's usually inferring time. Yeah. Don't worry, we'll get to some worksheets. Don't worry, they're coming. They're just not here yet. Yes?
So, wouldn't that be distance since there's no, like, north and south or
True, but it's not going to typically give you two directions. It's kind of implied. Like, yeah. It's not going to say you're traveling 34 meters north and at a velocity north. it's kind of redundant, so yeah. Does that make sense? Good question. All right, let's plug in. Anybody not know why I'm putting numbers where I'm putting them? And anybody in here are like, are you just putting numbers wherever you feel like? Or anybody understand why I'm putting the numbers where I'm putting them? No, you don't understand? Okay, what I'm doing, velocity equals this. So I'm taking this number and putting it and replacing v. They equal each other, so I can take v and put in that number. Does that make sense?
Yeah.
Here I know that my change in x is 34, so I'm coming over to my change in x and I'm putting in 34. Okay? What Katie just did is what you all should do. There's no dumb questions. If you don't know, you're only dumb if you say nothing. Does that make sense? Okay? Now, I want to quickly, I know the timer went up, but I want to show you what you have to do here, because what is the case about this here variable? It's not on the top. So there are actually quite a few ways to get it on the top. Okay? I think one is the easiest. There is the cross multiplication method. You guys know what that is? This times this equals this times this. Okay, that's one method. The easiest method, I think, is the reciprocal rule. Everybody know what a reciprocal is? Okay, you flip your fraction. Okay, well, this isn't a fraction, Mr. Kramer. Well, yeah, it is. Everything's a fraction. Is that a fraction? You see how I can take and flip them both? Okay, why do I have to flip them both? Okay, but why can't I just flip
Because
this
you
one?
have to do it on both sides.
Why? Because it's equal, right? And the third way would be just moving the variable, but that's probably the most difficult way. So let's do the reciprocal way. So I'm going to flip them both because it has to maintain equality. That's a 3, by the way. Everybody see I just took the reciprocal, I flipped them both. Anytime you got a variable on the bottom, that's usually the best way to do it. Simplest way. Because now I can get rid of the 34. How do I do that? Multiply both sides by 34 because I'm dividing. So I have to undo division. Now, where would it, like, if I'm multiplying, does everybody understand that when you're multiplying, you could put it on top of a fraction? If you're dividing, it's like putting it on bottom of a fraction. Okay, so all I really need to do is put the 34 up here. If you want, you could do 34 meters times 1 over 23, but it's the same thing. Does that make sense? So 34 divided by 2.3, anybody got a number?
14.8.
14.8. That's right. And it's in seconds. Okay? Worksheets are coming, probably after tomorrow. Well, probably homework for tomorrow, I would guess.
Homework on Friday.
What?
Gravy.
This